Okay, so welcome everybody. My name is Denis Didier Rousseau. I am the program chair of this meeting, and I am convening this session with my Japanese colleague Atsushi Higuchi from Chiba University. So the 21st century witnessed an apparent increase of large natural disasters. In fact, it has been reported that the total amount of damages in the 2000s was five times larger than that of the 1980s. It seems that the increase of global population and rapid urbanization made the natural disasters more complex and composite in nature. In such a context, what is the role of geoscientists? Do we really need a geoscientist or geophysicist? And if so, how to suggest vocations among the young generations? So we anticipate that this special session will be particularly stimulating and that it will provide useful comparison of single situation in two countries or regions with different educational and societal contexts. This union session, is held as a joint JpGU-AGU union session. The first and second sessions were held in 2016. The third session was held this year in Chiba during the JpGU-AGU joint meeting. And this fourth session, held in New Orleans, will address climate change and natural hazards related issue, focusing on volcanic eruptions and floodings from the three aspects which are on the screen. So we have a panel composed of colleagues from USA and Japan. So I will go through the alphabetic order. So Professor Victor Baker from University of Arizona, Professor Alan Robock from Rutgers University, Associate Professor Takahiro Sayama from Kyoto University, Professor Gavin Schmidt from NASA, and Professor Atsushi Toramaru from Kyushu University. So we will start by the first topic, which is the facts. How well do we understand natural phenomena like global warming, flooding, and volcanic eruption? So I have a first question to the panelists. We are today in a region which has been heavily impacted by meteorological events leading to severe floods. Is the increasing number of severe floods events related to global change? Maybe I can ask Gavin to start replying on this.
So the question is whether the issue...
It's not on.
So the issue is whether New Orleans and Katrina is part of global change?
Yes, the increasing number of severe floods events related to global change. Yeah.
Well, so, I mean, the globe is changing in many ways, and there are some things that are associated with global climate change. Increasing intensity of precipitation is a very clear aspect of that. Increasing global sea level is a very clear aspect of that. But a lot of the elements that make up a greater vulnerability or a greater occurrence of disasters are associated with other changes. I mean, in Louisiana, loss of wetlands, compaction, sediment loss from the Mississippi, the number of disasters that are befalling the Louisiana coast is much greater than global climate change alone. And unfortunately, all of them go in the same direction to increasing the damages from storms, from sturges, and from erosion. We have to be thinking about these things in the context of the other things that are changing as well, including habitation patterns, construction, infrastructure building, that are putting things in harm's way beyond what would be changing just from like the background climate state. Yeah. So, the changing climate is embedded within, a whole set of other changes which are, in particular places, are all amplifying the risks and the vulnerability of certain populations and areas.
Yeah. Other comments or from, yeah.
So I'd like to agree with what Gavin said, but also say that a little, where Gavin and I lived, there was a terrible hurricane 5 years ago, Sandy, and it was responsible for a large loss of life, a lot of damage, even though the wind speeds weren't that strong. And it was more damaging because of the climate change that's already happened. Sea level is a little bit higher, and so the flooding was a little bit worse. The ocean's a little bit warmer, and so the storm was a little bit stronger than it would have been without global warming. So on top of the vulnerability based on where we live and how we protect ourselves, climate change is part of the story in making these more damaging.
So in Japanese case, we have basically two different kinds of floodings. One is more like flash flood type, which occurred due to the, say, 3 hours, 4 hours, very severe rainfall. For instance, we had this very severe flooding which killed almost 40 people in this year in July, caused by 800 millimeter of rainfall in 6 hours, 7 hours in Kyushu, northern part of Kyushu. Yeah. And those kind of very severe storms seems to be increasing. And this fact actually has been detected by the kind of statistic analysis of the rainfall over Japan. So this kind of flooding is could be increasing in the future, and we should be prepared for that. And the other flood is a little bit larger scale floodings, which can led by typhoons, like cyclones. Mm-hmm. And how the typhoon will be changed or has been changed has not been very much realized yet. So we still do not know very much, though there are some predictions conducted by Meteorological Research Institute, for example, in Japan.
Vic, do you want to add something?
Yeah, I'll give a little different perspective. My career in studying floods goes back 50 years. And I've been very different in how I studied floods, in that most flood studies are done on little floods, and extrapolations are made to the big floods. This is because you can get a big sample of little floods. The time scale that would tell us about extremely rare floods has to be very long, hundreds of years or thousands of years. That has been little studied. So when we hear that floods are unprecedented in the newspapers and the like, it is out of ignorance that statement is made. The only records we have of hundreds and thousands of years are paleofloods that we study geologically. And this is something that my students and I have developed over many decades. So what we find is that in nature, floods do change. There are periods in the past that have clusters of very large floods. And what we have seen is that currently we are in a period that has clusters of very large floods. Now, the only way we can adequately understand that is not simply with theoretical models. We need to study reality, how floods actually work, how they actually behave. And very little of that research has been done. We are here in New Orleans, which in 2005 had a major flood disaster. Flood scientists know that in the United States, New Orleans is #1 for the likelihood of flood disasters. It was founded in 1700 by the French on a levee of the Mississippi River, which is a high point. Levees are made by floods. It flooded the next year. There could not be a major city in a place more likely with a higher probability of having large floods than New Orleans. So there are many things about floods that require a much broader understanding than most of the science that has been devoted to it. So I think we are, at least as far as large, rare floods, are in a state of very imperfect knowledge.
So, any comment on Vic assumption? No. But both US and Japan have experienced floods which were linked with another natural disaster, like hurricanes here in the Gulf states or earthquake in Japan. Is this something exceptional, or if not, can this be reproduced in the future, in the near future? Oh.
I don't really understand what you're asking.
You have events, floods, which are related to some exceptional natural disasters. Is this an exceptional event, or is this something which can reproduce on, has it been studied previously?
I also do not understand exactly. So because that's the question is concerned somebody, so coupling with different stratosphere, so solid earth and atmosphere. Yeah. So you mean that one?
When in Japan, you had a severe flooding with
no serious flooding, no, not serious, but compared with so United States case.
Yeah.
So what do you think about it? Serious,
Seriousness.
Not serious compared with the United States magnitude of the flooding, because Japan has no big hurricane like the United States.
No, but you have earthquake.
Yeah. So so that question, back to the question. So what you're asking is so some.
I was speaking about the coupling of these disasters. I was mentioning the coupling of this disaster.
Coupling, coupling.
Yeah.
So just, I have no idea about if the mechanism.
Yeah.
So if any coupling. So and also I have no data of such a coupling. So the very rare events.
Yeah.
So there are no statistical data.
Okay.
So
let me say, one of the types of flooding that occurs is associated with hurricanes or typhoons. In fact, the greatest danger from them is from flooding. It's not from the wind. It's from the additional water that comes from both the storm surge and the accumulation of water. And in the U.S. this year in Houston, there was additional flooding because everything's been paved, and so there was nowhere for the water to go. But the proximate cause of the flooding was the hurricane, where the water came from. So that's sort of how it happens. I'm not sure if you call a hurricane a disaster and a flood a disaster, then yes, they're actually part of the same thing.
Yeah.
But not all floods are associated with hurricanes.
No,
there's a lot of synoptic scale flooding that occurs that is really just like large scale water conversions, and people have done tests on that to see whether those are being affected by the underlying climate changes that we're seeing, and the answer is yes. We're getting more intense synoptic scale flooding because of warming of the oceans and the associated climate changes.
So if you talk about the coupling of different types of the hazards, what we experienced in Japan is that the very severe storm caused the landslides, and landslide creates the so-called landslide dams, and which causes the ponding before upstream of the dams, and then collapse those dams again, causes debris flows or sediment issues in the downstream, which magnifies very much on the flooding because of the very high depositions of the sediment on the river, and then the rivers are completely filled by the sediment, which causes the spreading of the flooded water. So it was very much difficult actually to predict, as we typically, when we do flood forecasting, for example, we assume there is no sediment kind of associated disasters. So it is kind of a multi-hazard type disasters we have.
Okay. No more.
So we have two type of decoupling. So one is just some very, very deep. So coupling in the mechanism, just something we don't know at all. So coupling in the source of for instance, some meteorological change induce some pressure change in the crust, and then something happened. That's a mechanism, like a mechanism-based coupling. But so the another type of the coupling is after event coupling, or just the coincidence of the event. For instance, as Takahiro said, for instance, in the Unzen eruption case, just the Unzen volcano in Kyushu, have very big, not so big eruption during the 1991 to 1995. So the many pyroclastic flow occurred, more than 1,000 events. So each of pyroclastic flow is very small, and also that's a rainy season, and such a hurricane or typhoon not so big, but that's a coincidence or so synchronizing such a both different type of the hazard, just make very big disaster. That's the after type of the coupling, I think.
Yeah. Okay.
Alan, I think the case you may be thinking of in the U.S. was Mount St. Helens eruption that pretty much melted all the snowpack on Mount St. Helens and flooded out.
You have a microphone. You have a microphone.
The case for the U.S. was the Mount St. Helens eruption in 1981, I believe it was, where all the snowpack was melted off within hours and flooded the Toutle River and took out bridges and killed quite a few people from the flood aspect, not just the volcanic eruption aspect of that disaster. That's one coupled case. The second one is the big landslide in Utah that blocked the river flow out of the Wasatch toward Salt Lake City, took out the road, took out the railroad, and they were both out of operation for about 6 months while they had to build a new route through the mountains.
Thank you. Vic, you want to add?
One of the issues that possibly relates to climate change for these coupled effects is that the latitudinal reach of tropical storms may be changing, and that tropical storms may migrate into higher latitudes because of the changes in sea surface temperature and the like. And this means that there's a prospect of the kind of disaster that occurred associated with Pinatubo in the Philippines, where there was a immense tephra generating volcanic eruption, putting lots of volcanic tephra on the landscape. And a tropical storm came in right after that. It generated tremendous lahars, and that was really the major economic effect, even in a larger sense than the than the volcanic eruption was because the lahars can be very widespread, and that was a source of the disaster. So the prospects of this from sort of volcanic eruptions coinciding with a tropical storm event, I think, are increasing.
Yeah.
And in the Philippines, the roofs were not designed to hold any weight because normally it just rains. And so these huge stacks of ash that got wet collapsed many buildings, and that was also a great source of danger in the Philippines.
Yeah. So this is great because I wanted to move to the volcanic eruption. So,
Yes.
so about asking the effects of volcanic eruption on climate according to the different areas. Or, yeah. Is there any cooling?
What are the effects of volcanic eruptions on climate?
Yes.
How long an answer would you like?
Go.
Short.
Short one, okay. Large eruptions that are strong enough to put sulfur into the stratosphere create a cloud that then interacts with solar radiation, and that cools the surface and heats the stratosphere. It also changes atmospheric circulation, so it reduces the summer monsoons. It produces winter warming, a stronger Arctic oscillation over northern hemisphere continents. We also just published a paper showing how large eruptions can induce an El Nino, increase the probability of an El Nino the next winter, and they also destroy ozone now that there's chlorine in the stratosphere that then produces more ultraviolet radiation. A large series of volcanic eruptions at the end of the 13th century cooled Earth enough to change the circulation into the Arctic Ocean and make a perpetual cold Arctic, which was responsible for the Little Ice Age, which has lasted from 1257 or so until the 19th century when greenhouse gases have warmed it up. So there's impacts on many different scales of large volcanic eruptions.
Gavin,
You can go back even further and the impacts are much, much larger, right? So one of the interesting things, if you look at a lot of the hypothermal events in the paleoclimate record, so the PETM, which was 55 million years ago, some of the other small events in the Eocene, the Permian Triassic, the Terratian, ocean anoxic events, a lot of these very, very warm periods were associated with volcanic intrusions into organic matter, releasing a lot of carbon dioxide, a lot of methane, that changed climate by 4, 5, 6, 7 degrees, causing massive ocean anoxic events, extinctions, and very radical changes to the climate. So they can have very important warming effects as well.
Yeah, if you want to go back like the Siberian traps 250 million years ago,
right.
That was a huge, massive volcanic eruption which caused mass extinctions.
Right.
And more recently, the Toba volcano in Sumatra, 74,000 years ago, produced so much cooling, we think it was a genetic bottleneck. Most humans died, and we're all cousins, we're all descended from the few people that were lucky enough or smart enough to survive.
But the Siberian traps and the Central Atlantic magmatic province igneous event, they produced massive warming that caused
That's
those
right.
extinctions.
So volcanoes emit
yeah.
lots of different things, and so it depends on the scale. That's right.
But until recently, there were no major volcanic eruption as we have observed in the very past. Can such major eruption happen in the near future? Are we able to predict such event like the one we just been? No.
The simple answer is no. Even after volcanoes start rumbling, you don't know whether there's going to be a large eruption or a small one. Agung in Bali, which had a major eruption in 1963, the first major eruption in 51 years, is rumbling now, and they've warned people to get away, and the eruptions so far have been rather small, they produce lahars and danger for people nearby, but I doubt it has enough juice to get stuff up into the stratosphere and cause global climate change. But nobody knows. Volcanoes start rumbling, and even after they do, you don't know whether it's going to erupt or not. Mount St. Helens in 1980 and Pinatubo in 1991 were rumbling for about a month, and the volcanologists warned people to get away, and they did erupt. So, but if you warn people to get away and it doesn't erupt, then somebody steals their cattle or whatever. It's a very difficult problem to know what to say.
Yeah. Gavin? No? And what about Japan?
Yeah, I agree. But,
Yes.
Yeah, I agree. But but sometimes we have a very lucky case. It's just like a Sakurajima, so very small eruption, very small eruption. That depends on the scale.
Yeah.
Yeah. So the Toba case is a very large eruption, VI7 something. So the volume of the magma is up to the 1,000 cubic kilometer. So very big, 1,000 cubic kilometer, you can imagine. So 10 kilometer, 10 kilometer, 10 kilometer magma. So instantaneously erupted. So that's very huge. So and normally, normal caldera forming eruption is 100 cubic kilometer. So, but that's maybe the 1,000 year each 1,000 year or each 10,000 year. So, but a more frequent eruption, the 1 cubic kilometer, so eruption is just more frequently occur. So that's 100 year per 100 year, 1 or 2 per 100 year in Japan. So in such a case, its impact on the climate is much very rare, or sometimes very locally if happen. So but practically, I think that it's very important to understand the interaction or the effect of the eruption to the climate for such a relatively small scale of the eruption.
Yeah, so I have a question for Gavin, because he's a modeler. How appropriate or reliably can you model the impact of volcanic eruption on your model?
If you'd asked me that question 5 years ago, I'd have said, oh yeah, no, it's a solved problem. Like, I don't know why anybody's even asking. But then it was clear after CMIP 5 that that what we had done for volcanoes was actually not very realistic. And so we spent a lot of time going back into thinking about, well, what should we be doing? And should we be doing this as a first principle calculation, putting in sulfur dioxide, sulfate, water, and then seeing the chemistry evolve? And we are now doing that with forward modeling point eruptions in the climate system as a whole, and actually getting very realistic results. Now, there are a number of aspects that, as you go further back in time, there are some real uncertainties. Like, what was the composition of any particular eruption? How far did it go into the stratosphere? What month did this big eruption in 1257 go off? No, and that actually makes a difference to where things are deposited, how things get transported across the hemispheres. So there are, obviously going back further in time and for the bigger eruptions, more and more uncertainties. To what extent do particles glob together when there's a very large eruption, like perhaps for Toba? Those are real questions. But we're now, I think, much better equipped to really explore those uncertainties in a proper way. So we can try a whole bunch of different things and then get a kind of probabilistic estimate of what the impacts would have been in ways that are much more credible than they were 5 years ago.
Yeah. Because if I remember,
So the basic response from models is pretty good. You get cooling, you get warming in the stratosphere, you get changing circulation. You do get winter warming after the biggest eruptions of the past 150 years, Krakatau and Pinatubo, from if you average all the CMIP models. But as part of CMIP 6, we've organized VolMIP, the Volcano Model and a Comparison Project, and we wanted all the modelers to do standard eruptions. So we chose Tambora, which erupted 200 years ago and produced the year without a summer. And we wanted everybody to use the same distribution of stratospheric aerosols. So we asked 5 state-of-the-art models like Gavin described. We put in SO2 on the equator, the same location, produce this distribution of aerosols, and we can just maybe average them and have all the models use it. And we were surprised how different the results were from these still state-of-the-art models. Some of them went to the northern hemisphere, some went to the southern hemisphere, some came out much more quickly. So we're still a ways from doing this forward calculation really accurately, and a lot of different modeling groups are working on that now.
Can I ask a quick question about your subject, and that is about whether or not we would predict and whether the paleo record shows that changes in ocean temperature and sea level would impact kind of the likelihood of change of tectonic shifts and that kind of thing, and whether we see that in the paleo record with all the, if we're able to correlate volcanic activity and sea level rise and temperature, density, etc. And
So you're asking, can climate change cause volcanic eruptions?
Yeah, ocean temperature changes and sea level changes.
So the answer is a little bit, yes. So during the deglaciation, so you have a massive shift of water from the land to the ocean, like 120 meters worth of water. There is some evidence that volcanoes in Iceland, for instance, were more active after the weight of the ice was removed, and so there's some evidence for that kind of feedback. Now, for a lot of places where it's the volcanoes are being caused by kind of subsidence plates, that subduction. Yeah, I mean, so in Japan, I don't think you'd probably see such a relationship, but you maybe want to comment on that. But for some places, the release of the ice weight or the shift of the water does in fact make enough of a difference to make a difference.
In studying the past, we get into the issue of whether correspondence and correlation is associated with causation. And we are led to a hypothesis that there may be a causative effect if we find the timing of a phenomenon like a volcanic eruption and then some climate change related phenomenon coincide. But to resolve this, we need much more information about what was going on in the past. So we need to use multiple forms of evidence. One intriguing thing related to my own work, which is focused on the study of the largest floods that have ever happened. I study really big floods. And in the United States, the one that is dominant that I've studied for a very long time are the cataclysmic late glacial floods associated with the Cordilleran ice sheet. And our dating shows a prominent peak in that flooding at 16,000 years ago. That also is a time of a massive Mount St. Helens eruption. So the flooding was hundreds of meters deep in some cases. So it would have put huge stresses on the course of the Columbia River Valley where the flooding occurred, and Mount St. Helens lies a little bit north. We don't know if that's a causative relationship, but it's the kind of problem we have in looking at these evidences from the past in regard to multiple events.
Okay, so I think we will move to the second point, which is communication. So I would like to know are the modern societies prepared to the various flooding events, including those of extreme magnitude? In US or Japan, in Japan, populations prepare the same way to these events or not?
For which events?
The flooding.
As a flood person, I will give one statement that says a lot about the status of communication about extreme floods. I will quote a presidential tweet. Wow. Now experts are calling Harvey a once in 500-year flood. There's many dimensions to that statement about communication.
Can you elaborate?
The whole terminology of a once in 500-year flood is the biggest failure of communication of the nature of flooding that could ever have been devised. Mm-hmm. It has nothing to do with real years. It has nothing to do with real floods. It is a probabilistic estimate that was designed for the insurance industry so that it could ensure that insurance premiums could be set in order to not lose money. The U.S. National Flood Insurance Program has lost incredible amounts of money. So the whole program has been a disaster. And of course, it's about disasters.
Yeah.
It has nothing to do with real floods. And moreover, it's estimated from statistical samples of small floods. So it's completely unscientific. In fact, it's anti-scientific. And yet it's perpetrated on an unknowing public, misleading them in the extreme. So it's the type example of poor communication. And unfortunately, it is perpetrated by people who are hydrologists, without question.
I think it's a little harsh, frankly. I mean, this is not the only place in the world where people make extrapolations of what the generalized extrema are in a distribution based on a limited sample. What are you supposed to do? People do need to price risk, and you do the best that you can at calculating what the extrema are. Now, there's a whole set of theory on like how to do that. You don't just assume that it's normal or something. And they can be doing it well, or they could be doing it badly. And I agree that they could be communicating it better. But to claim that the very notion is anti-scientific is a step too far, frankly.
This isn't my view.
It isn't your view.
It is. Well, I tend toward this view, but I'm actually citing other views. My hydrologist friend, the late Vit Klemish, wrote extensively on the poverty of flood frequency analysis as both communication and as a scientific enterprise. But we have a much more recent example, which is the study of extreme disasters that is been popularized in the book The Black Swan, which has pointed out that our huge disasters are occurring. And he talks about the stock market, he talks about major earthquakes, he talks about lots of big disasters. These are outliers in statistical analysis. Outliers. There's no way to use the small samples to say what those outliers are. And what he's saying is the statistical samples are irrelevant. It is the big things that matter. This is his argument. It's a 500-page book, and he is a statistician. And I think we have to think about that carefully, scientifically, and it is an important issue in communication. We are infatuated with probabilities, but the big things are possibilities. They are possibilities that have been realized in the past. Another part of Trump's statement is experts tell us. The possibilities are given to us not by experts, a game manipulated by politicians. My experts will fight with your experts. The possibilities are given to us by nature. And the people who dispute nature are not experts, they are crackpots.
Okay, hold on. But there's no nature that just tells you what happened in the past without the intervention of experts who go and find those sediments and interpret those sediments and make time scales for when these things happened and what occurred and what correlated with what, right? So there's no information without experts. Right? There's no nature. There's no person in the sky telling us what nature is capable of over millions of years.
As far as communicating flooding is concerned, I'd like to keep it simple and suggest that there's no risk of flooding on a floodplain. There's merely a guarantee. A simpler way to put it. You can get involved in numbers, but people can manipulate those.
Well,
if it's a floodplain, it's going to get flooded.
Well, there's a very good article in the Times 2 weeks ago on how people manipulated what the floodplain line was in order to create new subdivisions that all flooded in Harvey, and everyone is like, but we're not in the floodplain, it's so unfair, which is kind of clear.
The word floodplain has multiple meanings, and the way it was defined by the National Flood Insurance Program has nothing to do with reality. It has to do with model projections that are based, they can be done by an engineering firm in New Jersey. The engineering firm is more interested in a procedure for generating a line on a map. A floodplain in geology is a feature that is made by flooding. It consists of sediments that are deposited by the river. So in that sense, it is an absolute certainty that that area will be flooded. And the probability analysis is really just a sampling of the appropriate amount of data from which to generate that probability estimate. But the National Flood Insurance Program, which I began to talk about, is not based on any physical understanding of rivers. It's based on a game of numerics designed for the insurance industry. And it does not communicate to the public appropriately. The public thinks there's this magic line. They pay insurance above this line, they don't pay insurance below that line. Yet, it's very clear to people who can understand a place that has been flooded in the past will flood again. What has happened can happen. That's an absolute certainty. I'll give an example. I did study, and this relates to Japan. I had the opportunity to go into the field in the northeastern part of Honshu shortly after the Tohoku-oki tsunami. And I visited cities that had been totally destroyed. It looked like a nuclear bomb. And the estimates that were made probabilistically of the flooding by standard procedures resulted in what is probably the largest dollar damage disaster so far in world history. And of course it was the effect on the nuclear power plant, the Fukushima plant. The calculation was made by probabilistic risk assessment, probable maximum tsunami, probable maximum earthquake, routing the tsunami. The seawall at Fukushima was designed at 5 meters high for a 1,000-year event. The tsunami wave was 15 meters high. And Tokyo Power and Electric ignored a geological report published 10 years earlier that showed 1,000 years ago a tsunami of that magnitude occurred in that area and left geological evidence of that event. This has not really been talked about enough in the news. So it isn't so much about our ability of experts to work out this probabilistic analysis. The physics of the models may be right, but the assumptions about what nature was really doing, what really caused it, those were wrong. When nature makes something happen, it is right. It is absolutely true because it has happened. Now, in villages, towns I saw in Japan, they had hazard areas. There was one place with a 3-story high hazard center where the people climbed to the top and were all killed. Another place I went to in Japan was called Anyoshi. That had the highest tsunami surge of any place. It had a 40-meter high surge for that village. No one was killed, hardly any damage occurred. And the reason was there were signs from the ancestors on stones that said a tsunami of that height occurred in the past. And the people did not listen to the government and the experts. They took the reality of what they saw and obeyed it. And there was no damage there. And no, they built above that level, a reality. So this is a communication issue that I think scientists have not paid enough attention to, and one that we have to really emphasize if we want humankind to be communicated with appropriately about future disasters.
You want to add something?
Yeah, I would like to add one experience from Japanese flooding occurred in Tokyo, near Tokyo in 2015, 2 years ago. What happens is that a lot of people live in the floodplains where we have a flood hazard map indicates that all the areas are very critical, very dangerous place. In fact, they experienced about 20 years ago, the same place were flooded too. However, the communications issue is there in terms of, for example, flood forecastings information and the people who receive those information. And to kind of expect what will happen in the coming hours and how to behave, how to evacuate, it's really challenging and has not been very much efficiently conducted. And as a result, more than 1,000 people were rescued by helicopters from the floodplains. So there are a lot of informations were issued, but those informations were not very much maybe miscommunications in some sense between those issues, flood warnings, and those residents to evacuate. I think this is
if I follow you, on both countries, the populations are not well prepared to face such big events. They don't know. They don't know exactly how to behave. Is it what you are saying? Or they are, for example, in Japan, you are well prepared in case of earthquake. You know what to do, but in case of flooding, if I follow you, this is not at the same level.
It's very difficult to say, as sometimes even if we know, for example, in the Kyushu case which I talked about, it is really difficult to cope with. So for that answer, it's very difficult to say, I feel, because sometimes how can I say, the people are ready, but then, how can I say, still cannot do anything. That is also the case in severe storms case.
And apparently in USA, there is no preparation at all for the population to face the floods?
Well, there's a lot of formal programs, like the flood insurance maps by the National Flood Insurance Program. They have been used as flood hazard maps, but they were really, going back to the 1960s when this program was established, it was an attempt to have the people that occupied hazard zones buy insurance so that that insurance would then pay for the effects of that. So the idea was good, but it doesn't communicate the nature of the hazard. People just think of it in terms of they have to buy insurance or not buy insurance. In the Harvey flooding, there were immense areas of flooding that were in the 500-year floodplain and actually outside the 500-year floodplain. In other words, it was completely not even in the hazard zones. Mm-hmm. In my own town in Tucson in 1983, we had areas that had been mapped by FEMA as 500-year flood zones. The stream eroded into them and undercut and damaged buildings by erosion outside of that zone. And of course, erosion isn't even a process that FEMA includes in their hazard analysis. It's a very simplistic kind of analysis. So a far more effective way to communicate to people about flooding would be to demonstrate where flooding has actually happened and have them recognize that that is possible and that is a zone where they have to be cognizant of the vulnerability that they have in that zone. And the idea is that nature and reality is really presenting the hazard to them, as opposed to experts saying where they should build, you know, this is this zone, that zone.
Doesn't that rely on the idea that everything is stationary and nothing is actually changing on the long term?
Yeah.
Well, things are always changing, so that nothing is, stationarity is an assumption made by statisticians in order to, and mainly by engineers, because engineers are not scientists. Engineers are trying to efficiently utilize the available information to come to a solution. Right. But it's under conditions of limited money, time, and those solutions, good engineers know they are not going to last forever. They're only temporary, and the changing conditions mean that the solutions have to change. So that's part of our problem is that we're experiencing change more rapidly than has been envisioned in the kinds of designs that have been done. Japan has invested much more in infrastructure relative to its population than the United States. And this is because Japan, it has a high population density, and it's mostly in alluvial plains. 80% of the country is mountains, and the alluvial plains are where the whole population is located. So Japan has invested a huge amount of money in constructive works to channelize lahar flows, channelize pyroclastic flows to deal with flooding, much more than the United States is able to spend because of the size of the country and also the lack of investment in the U.S. in infrastructure.
So, can we move to volcanic eruptions? Maybe. So, we were speaking about major eruption, but what would be the impact of such major eruption on the adjacent or national neighborhood? What would be on the population, at the population level? Are the population prepared to face major eruption? in US or in Japan. In Japan, I think so.
Yeah, very interesting to hearing your opinion on the engineering and scientists. So because so in Japan, basically Ministry of Infrastructure and Land and Infrastructure and some transportation that covers such a issue. So for the protecting the such disaster. So and also the meteorological agency, Japan belongs such a department. So that's very nice structure. So but meteorological agency consists of the many scientists, including many scientists, and to provide the many data, the meteorological data and some earthquake data, volcanic data. So gathering all data of the natural hazard. So and that belongs to the that's a more upper level of the Ministry of the Land and the Infrastructure and Transportation. So that's very nice structure. So however, something wrong. So not so good way. So because that's problem. That's a similar problem for the volcanic eruption. So and also the more complex things in Japan. So such as preventing disaster or the control for such a disaster when such a natural hazard occurs. So that only local government can control. So for the human people, how people can do or how people do for such a disaster. So that's a structure a little bit good for in the national level. So that's so basically Minister of the Land and Infrastructure and Transportation consists including the specialists of the engineering specialists. But sub scientific, the meteorological agency, so that's scientific. So but a little bit I think that's a structure. There are problems in the structure, and also that's a control for the people to evacuate from the hazard disaster. So that's the local government control them. So that looks nice, but a little bit wrong. So I think.
And in USA, Alan.
Well, I'm not a volcanologist, so I can't really talk about the immediate danger of the explosion and the rocks and the pyroclastic flows, but I could talk about and as I said, volcanic eruptions can't be predicted. You can find when they're active, but sometimes you're surprised. But as far as the atmosphere, there's a network of volcanic activity advisory centers, VAC. There's 8 of them around the world, and they're prepared to warn aircraft of clouds in the atmosphere that might be dangerous for flying. And so once there's an eruption, they will use remote sensing to figure out where the ash, the particles, and the gases are. They will run trajectory models to tell where it's going to go, and they will advise aircraft on where they're going to be. After the Eyjafjallajökull one in Iceland, they, I've been practicing, they warned where the ash was going to be, and the limit for what the concentration was that the airplanes could fly into was 0. And so the planes just stayed away and lost billions of dollars when they could have spent millions of dollars in calculating how thick the ash could be and still fly safely. They've done that since then, and now they have a criterion, I forget what 2 micrograms per cubic something. And so now that they know they can sort of not be bothered nearly as much as they were then by staying completely away. So there's a plan to make aircraft safe and to not fly into dangerous aerosols. As far as climate change, we have modeling capabilities now at NASA and other places where they can put in the observed emissions and calculate how the climate's going to change over the next week, month, and season, and do a better job of forecasting because that's something that will be around for a while. And so we're prepared for that also.
But you were speaking about aircraft, but can there be economic impacts of this, long-term economic impacts of this volcanic eruption?
Yes.
So.
But that's not my area of expertise, how much obviously they lost a lot. If planes don't fly, they lose a lot of money, and people get very inconvenienced, and things don't get transported locally. That can be damaging. Of course, it can damage the infrastructure locally and kill people. But I'm not sure what that's. Are you asking for something more sophisticated than that? That's
no, it's okay. Okay. It's okay. But because I was also thinking about you have a very specific body, I would say, in Yellowstone. You have something which is supposedly to erupt sometime.
What is it?
The Yellowstone supervolcano.
Yeah.
Yes.
Well, yes. As Vic said, it's erupted in the past and it's going to erupt again. We're sure of that. But it erupts sort of every 600,000 years, and so it doesn't look like it's going to erupt anytime in the near future, but that's not my area of expertise. I imagine it would start giving lots of signals beforehand, but I don't know.
Well, actually, the last really big eruption was 600,000 years ago, and it had one at 2 million, one at 1.2, and then one at 600,000. So within the next 100,000 years, but I mean, that requires a lot of magma doing a lot of stuff. That could be anticipated, but it might be, centuries before anything would happen. I mean, one of the problems we have is this idea of prediction. The public thinks prediction is saying what the future will be. That's not what we mean scientifically. In science, we use prediction as a tool as part of our scientific inquiry. So when we make, let's say with an atmospheric model, a prediction, we're utilizing that as basically a deductive system following from the physics and the mathematics to help us understand the atmosphere. And that's a very different thing than being able to tell exactly what's going to happen in the future, which is the way politicians and the public think of it. And that's been a communication problem. It's led to a kind of false conflict among the people that are arguing that these are very imprecise in terms of telling the public what is true, so-called experts on one side versus the people validly doing science. And for me, science is the passionate, pure, unfettered search for the truth of things. And the good scientists I know do that. There's other people that try to present arguments that look good because they have some purpose, and those people are not scientists. But they get into a game of arguing about this concept of prediction, which, as I say, the words are meaning different things to different people, and that's part of a communication problem.
Did you bring an umbrella today? Did you bring an umbrella today? Did you bring your umbrella today? Your umbrella, the thing for shielding you from the rain. Did you bring it with you today?
My what?
Your umbrella.
Umbrella.
Oh, my umbrella.
Yes.
Did I bring it today?
No. Did you bring it today?
No, because weather is something that we can.
Something that we use models to make predictions
It's just like eclipses.
which are also predicted.
You can predict eclipses very precisely,
Right.
but you can't predict them a million years from now.
Well, it's hard to tell.
Because the physics that allows you to predict on the short time scale, the errors don't get large enough.
My point was much more a general one. You made a very sweeping statement about how no scientists make predictions because they're not really scientists, which quite frankly is a little bogus. You know, people make predictions about real things that have real consequences all the time based on our best understanding of the physics and the biology and whatever is going on. We make predictions for El Nino 6 months out that have a great deal of skill. We make predictions for weather 7 days out, which have an increasing amount of skill compared to what it was 20, 30 years ago. We make predictions for what's going to happen to the global temperature next year and in 40 years' time that do have skill. Now, they're not just games, they're not just us trying to understand the system, they're real predictions, right? So I don't understand why you think that predictions are somehow not scientific. You make predictions, you see if they come true, and that validates or disproves the hypothesis that underlies them. It's a fundamental part of science.
I was referring to the public and political understanding of predictions and contrasting that to what you're describing, which is what scientists try to do.
Right.
So I wasn't casting aspersions on the scientist who is passionately searching for the truth of things and utilizing prediction in that process,
right,
and is
good.
Quite validly interested in conveying what they have learned to the public. What I was criticizing is people that are not interested in that passionate search for things and are attempting to create arguments that belittle the process and rely upon the public misunderstanding that these predictions are something that has to be absolutely correct in terms of what the future will be.
So I don't think anybody
that is my
is
concern. I'm not concerned with the good work done by scientists trying to understand the atmosphere and wanting to convey that seriously to the public. But communication is a two-way thing. It isn't just the scientist. It is how the public perceives it. And scientists have not paid a lot of attention to that aspect of how the public is receiving the message. We have ample evidence that the public is being manipulated in their reaction to the message. And that is something we scientists need to think very carefully about. It's partly our responsibility to think about that.
I think one of the issues is that the future is probabilistic. It's not completely determinative. So we could say the probability of rain the end of this week might be 30%, and that's very hard for the public to understand. And so they want to know yes or no. And so you're saying that the wonderful skill that we meteorologists have given to weather forecasts on the short term has spoiled people into expecting every prediction to be like that.
I tell my class that if the public understood probability theory, there would be no big city in the desert midway between Salt Lake City and Los Angeles. It's a good reason why geologists don't go into gambling halls, because the public doesn't understand probability.
So how to get the important message to the public?
How do we get the message to the public?
Yeah.
I think that having them properly understand probability is going to be a very long problem of education. And I think the public can understand possibility, they can understand realities, and that we have made a big mistake in trying to, I mean, probability analysis is great scientifically, and we use it as part of our understanding. But I think it is a real difficult thing to bring into the public sphere and have them properly understand it. Now, I'm talking from my experience with extreme floods, and maybe there's ways in which they can better understand it in regard to other phenomena. But I see a big problem occurring in disasters which are partly the result of lack of understanding of vulnerability politically and publicly, even though we scientists know that it is a big problem. The message isn't getting through to prevent the really big disasters. They're getting worse, and yet we are advancing our science. I'm saying this is a problem we have to think carefully about, and it's not just on the side of us scientists doing more and more of our standard kind of science. It's also on the side of how this message is being received and how action is taken in regard to it, and that is in the public sphere, the political sphere.
So do you think you have to provide the message to the public or to the policymakers the same way?
Well, I think we can try different things. When scientists are in doubt about things, they experiment. They try some different ways of communicating. And I think there's room for experiment, and we can learn from experiments in how we communicate these kinds of issues to the public. Science is not about absolutely knowing the answer. It's always for looking for a better question. And our question is, how do we communicate better to the public? We need to look more for a better way of doing that.
Yeah.
I think the key thing, though, is to remember that there's many publics, and that there's no one communication strategy that fits everything. You have to think about communication as an analogy I use is a ski hill, right? So there's many ways to get from the top to the bottom. There are gentle runs that take you there slowly, step by step, that are fine for people that have no background knowledge or skill. And then you can go down really, really fast on a very, very bumpy road down a double black diamond run. Now, communication has to be the same way. There are people who are totally capable of hearing your communication at the double black diamond level, and there are some people that really need a bunny slope to be led by the hand to get to where you're going. And you can't think that communication is one thing. There are many, many different audiences, many, many different values, and that there are some people who are very good at connecting their values with the values of their target audience, and other people who are not so good. So, I mean, like Catherine Hayhoe is a great example. David Titley is another example. Both have constituencies in the American public who are distinct, and but both are able to talk to their constituencies very well. David Titley is a military Navy person. He talks to people with national security, military backgrounds a lot. Catherine Hayhoe is an evangelical Christian, talks to evangelical communities in ways that peacenik, atheist Jews who live in New York are not able to, right? So there are, the principle, the first principle in any kind of communication is know your audience, and there are many, many different kinds of audiences, and therefore many, many different kinds of communication that need to be tried and used.
You want to?
Yeah. Well, what is important in disaster research in terms of the communication is, one thing is how to interpret the huge catastrophic events. What's the impact of those events on the society? And those are different from, for example, designing the structures. Like there is a potential that can exceed those designed levels, and what can happen if there's such significant event happens, both, for example, volcanoes, earthquake, floodings, and then making it kind of sort of predictions what kind of consequences happen in urban areas, for example, etc., is very important in terms of sharing the understandings of the possibilities, and then that will help us to kind of think about the countermeasures on that.
Yeah, please.
Yeah, we Japanese had the big event of Fukushima disaster. So at that time, you know, the communication is not good. For example, young guys do the nuclear simulation with the radioactive materials transportation. But this guy cannot stand in front of the public, to convey these messages, because there is some danger for the attacking by from, you know, if this simulation was wrong, then he couldn't be protected by himself. So the communication really not both directions, very difficult. Then reflecting this problem, the Science Academy of Japan made a framework of communication among the academic society. 55 societies now communicating with each other, making some framework. Then making preparation to such a large-scale event like Kumamoto type. The Kumamoto earthquake, at that time, there was first action was taken by this initiative. Then this body of the 55 society made a presentation, detailed explanation to the public and to the government. So that kind of system will be very important to be prepared or talk to the society from a science body. That's my comment.
You want to comment? No? No? No comment? So, if we move to the third point, what about the new generation? How to make it coping with these changes which are occurring, and how making it more aware of these changes? What about, are there changes which should be done through the education system or not? What is the...
As we said, you know, if you wait to change the education system before everyone can understand what we're talking about, we're waiting forever. So, you know, there are people that have not been in education systems for many decades who still need information, and who are still making choices that are putting themselves and their loved ones and their money in harm's way. So to say, okay, well, let's just fix education and that's our only response is an abdication of our responsibility. So regardless of what happens in education, which obviously should be better, there's no question people should be more numerate and more scientifically literate, we still need a concerted effort to communicate to people and to teach people in ways that they actually get their information. So by watching TV, by being on social media, by you know, having governments provide like larger scale efforts. You know, we can't not do all of those things.
Is it the same case in Japan? You are mentioning social media. Do you think it's a good tool to improve this education or communication?
Well, social media has its advantages and disadvantages.
Yeah.
The question is, how do you sort out what's valid and what's not? And I have no idea how to do that. People tend to, I think, listen to a narrow group of people that they already agree with and reinforce their past ideas. So why would somebody who's very, very conservative, listen to somebody who's in a different part of the political spectrum, as Gavin was saying. So even whether it's social media or some other means, social media is the way a lot of people communicate now, and so we have to learn, I guess, to make very, very attractive, catchy ways of communicating. But still, people will only listen if they trust you, and so I'm not sure how to solve the problem that way.
I had interesting story from my friends, the seismologists. So when the Kumamoto earthquake occurred, so he gave many times this large scale of earthquake should occur in the future for the public or local public many times. So interview for after the earthquake, the interview to the people, so they said, I didn't know. So but for the announcer or the interviewer interviewed the younger people, so they say, oh, I not so upset because I heard from my teacher in the school or my expert, very close to them. That's very important, I think. So we scientists give some lecture for the public. So one time or frequent, many times, and not so good, not so effective. So other way. So maybe school or the expert in the teacher or the expert in the school. So the daily give some daily explanation of the illustration. For you will have some very big earthquake or some very big hazard. So I think it's very important story.
Yeah, I think we do not fully understand the ramifications of social media. It's only the fact that with a cell phone, the billions of people on the earth who have them can take pictures of a phenomenon happening. I recently saw in social media a collection of pictures of holes developing in the ground and buildings, cars, people falling into holes. Okay? This is a geological phenomenon. We understand it, but pictures of this were happening in places all over the world. We only generally knew about this after the fact, but because people have a cell phone and they're there, they take pictures of it. And the social media thing on this was, well, this was some mysterious event, that there was some physical, quantum mechanical interaction occurring in the deep earth all over, and holes were developing and things were falling in. But there are geological explanations for all of it. Well, essentially this is a kind of teachable moment. People are interested in these phenomena and they are paying attention to them. If there was interaction with them, leading them on the path of their own discovery, of their own understanding, this would be an educational tool, as opposed to just communication in ignorance and coming up with conspiracy theories about it. So there's potential because of the natural curiosity factor that human beings have about the world around them and their willingness to pay attention to it. We can take advantage of that to have them better understand the risks and vulnerabilities in their environment. So it's just a minor kind of possibility that should be considered in a different kind of education.
But as the new generation is using more and more these social medias,
Yeah.
Do you think that the school programs should be rethought so that people would get some education about these natural phenomena much earlier, so that they would be able to evaluate by themselves what they are seeing, and instead of just following some people just who are addicted to this?
Well, there's an early childhood educator, Robert Fulghum, has written about a number of books, such as Everything I Know I Learned in Kindergarten, where he points out the anomaly that small children basically have immense curiosity.
Yeah.
So when I go into a class of kindergartners, first graders, third graders, they're full of questions.
Yeah.
I talk about something scientifically, and they want to know. But by the time they're in 5th, 6th, 7th grade, they don't ask questions anymore.
Yeah.
They think science is a bunch of facts. But the source of science is our curiosity, our willingness to try to think about what we don't understand. We kill that in our education system. That is something that we should take advantage of, that we should help that to blossom. When I get the students as graduate students, I have to reawaken that again. And that's a fundamental problem, and I think it relates to their understanding of the natural world in which they happen, the realities of that natural world. We could improve that understanding if we just modified our view. Let them develop the facts as they need them, as opposed to cramming it down the idea of the bucket on top of the head that you pour facts in. The alternative is you give them a flashlight to illuminate the darkness. That's a different view of education.
So following what you are saying, don't you think that this killing of the curiosity is partly responsible of this decrease in students attending or interest by natural sciences?
I think it's a problem. I mean, we scientists know you have to have a certain amount of the tools. As Poincaré said, our science is not a pile of bricks. You put it together and you use this to construct your theories. But that's going to work for the 1% or 2% that are going to be scientists. The larger population that needs to have an appreciation for science, we have to awaken in them that curiosity, that sense of wanting to understand, that thinking about relating to the world, that will help them in coping with these kinds of, reacting to the possibilities of these kinds of disasters that we know are occurring and that we worry about getting worse. Mm-hmm. So it's another idea about how we have to think about education.
So what about Japan? Oh, sorry. No, Gavin, go ahead.
So, I mean, the big shift in the last few decades has come from, just the diversification of sources. Now that it's so much easier to get information from more places, the idea of a broadcast model for getting information, an authority telling you what you should be knowing about and what you should be thinking about, is falling apart. So, central media is much less important than it used to be. Textbooks are much less important than they used to be. Newspapers are much less important. TV stations and institutions are much less important. The church, the government, people have less respect for them than they used to have. But if you actually ask people, who do they have respect for? Who do they trust? They trust doctors and scientists. And scientists. So if you ask people, it's like 80% of people think that doctors and scientists are trustworthy. Doctors are more trustworthy than scientists, but still very high. And journalists and politicians are way down at the bottom, right? So nobody trusts journalists, nobody trusts politicians, rightly so. And the loss of authority of big institutions, the church, government, schools, is totally understandable because that authority had been abused for many, many centuries and decades. So we're in a situation where the previous sources of authority have rightly lost their authority, and people are finding information from peer-to-peer networks rather than broadcast media. And quite frankly, we have not caught up with that, right? So the skills needed to navigate that new dimension are not being taught because we're still in an education paradigm that is very, as you rightly said, kind of top-down, fill people up with facts and then push them out into the world. Whereas we need to equip people with numeracy and literacy so that not tell them what books that they should have read, but that when they read a book, that they pierce through it, that they can see through it, that they can understand what it is that they're seeing or understanding. And that's those are very different skills, and it's not totally hopeless. I mean, I have a young 2-year-old who is boundlessly curious, and and we're trying to encourage that to continue. And there's lots of other parents and lots of other schools who are trying to do the same thing. It's not quite as hopeless as we think, but that's a long-term project.
Yeah.
The problem is to develop critical thinking and skepticism while you're trying to control unruly kids. And so it's much easier for the teacher to sit them down and do what you tell me rather than give them the freedom. And how do you organize that in a way that develops critical thinking? I think there are ways of doing it, but I'm not sure that that's a modern way of teaching, and I'm not sure how quickly that's being spread into the schools in a way that teachers are comfortable with, and people that want to evaluate them and test them and find out what did they learn are comfortable with. It's a little antithetical to that.
You wanted to say something?
Not very much, but I think it's quite analogous to what we have in the the authorities giving some kind of messages and also what to do in the case of the disasters, whereas the people are just waiting for those information and then if the information is not appropriate, then they just complain to the government. So how to change those structures is exactly the same as what we just discussed, I think.
And in Japan, the kids at school are introduced to science very early, or?
The elementary school.
Can you?
From the elementary school, just beginning of the elementary school.
Yeah.
So.
Okay. So usually I ask the floor questions, but I think that if there are questions from the floor, otherwise I think we will wrap up the session. I will ask you to give a statement one after the other. So can we start by our Japanese colleagues? Do you want to make a statement about this session? No? Okay, so just to conclude.
Let's conclude?
Yeah.
So maybe I have to conclude to how to educate the next generation. So prepare the big eruption, big natural hazard. So it's very important to educate or the teacher or the expert in the school in the younger stage of person, and to sometimes use some SNS or some such kind of information, so new kind of technology, I think.
Okay.
Yeah, as I said today, it seems like the way that communicate has been changing, as I said, from always learning from what the authority says, and so this will be, so we have, including how to use SNS efficiently for the disaster preparedness, etc. yeah, we have to restructure the way of thinking. So I think this is very important at this time.
Okay, thank you.
Yeah.
Alan, you want to?
Well, you told me not to talk about this, but thinking about volcanic eruptions as an analog and sitting next to two Japanese colleagues and having the Nobel Peace Prize having been awarded on Sunday to the ICAN, the International Campaign to Abolish Nuclear Weapons, reminds me that the greatest hazard to us is not from natural hazards, but from ourselves. And so, and nuclear war is the greatest threat, and we still have way too many nuclear weapons in the world. And so I spent a lot of my time working on telling people about that and trying to get the 9 countries that have nuclear weapons and the other countries that support them to realize that they can't be used and to abolish them. So Japan has refused to sign the new treaty to ban nuclear weapons that ICAN got through the United Nations this year and is one of the reasons they got the Nobel Peace Prize. And the U.S. is also ignoring it. The ceremony was in Norway, which is a NATO nation, and they're also not signing it. So that's one of the great challenges, is so that we can prevent ourselves from destroying ourselves so that we have the luxury of spending the time figuring out natural hazards.
Rick?
Well, natural hazards are an area where science has to think about beliefs, and I would define belief as that upon which action is taken. So we have ample evidence that disasters, which are the economic consequences of natural hazards, are increasing. They're getting larger. More and more of the problems are associated with the very biggest disasters, and this is occurring at a time when we are advancing our scientific understanding. So there's something amiss in this connection that's taking place. I think it involves the different ways in which belief gets generated in the sector outside of science, where the action is taking place. And the ways that belief gets generated is authority. And science has its authority, but there's other forms of authority. There's charismatic authority, that people invest in certain political leaders. Then there is tenacity, where people think the things that they've thought before, and they hold to the ideas that have always seemed to work for them. And then there is a rational approach that we think we teach in schools that is very logical, utilizes principles of reasoning, involves things like skepticism and the like. And then I think science is actually not any of these. I think that in science, there's a kind of humility in regard to how the world works, because we want to understand that. And the guiding thing in science is not our skepticism, but our fallibilism, that we know we can be wrong, but we are dedicated absolutely to trying to do better all the time. And if the public understood that, I think that would be something that we could work toward, because there's a natural human tendency to think that way. And I think we have lost that, and the hazard game is one where, I'm disturbed that things aren't working better in having the beliefs develop in a productive way for our future. And I think that relates to the beliefs in the nuclear realm as well. How do we get this across? That's a challenge. I don't have the answers, but I'm trying to state the problem. I think that's what scientists do.
So there are, I think, some reasons for optimism. One of them comes up in processes like the National Climate Assessment. So this is a process that the US has embarked on roughly every 4 years for the last 20 years, where you build communities at the regional and local level. You discuss with people, the stakeholders, what their vulnerabilities are to natural hazards and to anthropogenic climate change. And you work with them to build resilience. And one of the things that's happened through that process is that initially people did not talk to each other, they did not communicate, but now they do. And people did not realize that they were making assumptions based on a stationary climate, but now they know. And understanding what those vulnerabilities are, deepening that understanding across all the different sectors, agriculture, infrastructure, cities, and then having scientists go back to them with, okay, well, these are the things that might be changing, these are the places where you're vulnerable. It can be as simple as updating the flood maps. It can be as simple as thinking about, the level of the infrastructure above the high tide level. But it can also be very complicated, how apple growth depends on, the exact sequence of weather during the spring. It's complicated. But there are ways to build communities of knowledge and co-create better plans and better resilience. And so, it can be done. It's not being done universally. It's not being done for all problems. But it can be done. And obviously, I think it should be done more.
Okay, thank you. So I think that I will close the session, and I would like to thank you very much for this panel discussion. Sometimes it was a bit engaged, I would say, but I think that the audience will appreciate, or online, but also appreciate it in the room. Thank you very much again.
Thank you.